What runs down?
Okay, so that's the double bracket thing. Okay, we started recording. I'm starting recording this for Liddell and Keaton. Sorry, Keaton, I already did the first part of it before I realized that we should probably record. So I'll catch you up on the other stuff. Increasing, decreasing, and constant functions is the next part. So functions are increasing if they're going up from left to right. They are decreasing if they're going down from left to right, and they're constant if it's a straight horizontal line. Easy enough? Probably. So let's go down here and let's talk about the intervals upon which they're increasing and decreasing. So this guy right here, he is increasing from here to here, right?
Yeah.
And then does he all of a sudden become decreasing?
Yeah, it stays a little bit constant.
He stays a little bit constant, but he doesn't. He is gradually going up over time. Okay, so even though it looks like he's flat in the middle here, he is not. He is increasing all the way through. So what they'll have you do on your homework assignment is increasing, decreasing, constant. He is increasing from negative infinity to positive infinity, or you can write that as all reals. He is not decreasing, he is not constant. That's what he will look like. Okay, so when they ask for what intervals is he increasing, what intervals is he decreasing, what intervals is he constant, he's increasing the whole way through, he's not decreasing. Okay, we'll do the same thing for over here. Okay, the middle one, increasing, decreasing, constant. IDC. I don't care. Okay, increasing. He is increasing. I just start on the left side. He is increasing to start with until he gets to this point. Okay, now that means from negative infinity until this point, he is increasing. What is this point right here?
-1, 2.
We only care about the x coordinates. So from negative infinity to -1, he is increasing. Okay, then he starts to decrease. Between what two values is he decreasing? -1 to 1, he's decreasing. -1 to 1. Positive 1.
Yeah. And then from 1
okay?
to infinity.
And then he turns around and he starts increasing again, which is an x coordinate of 1 to infinity. So I'm going to put that up in the increasing again. Constant? No constants. Does that make sense? So that's how you write those. When you're doing this, you always label it with parentheses and never with brackets, because those points on -1 where he turns around and +1 where he turns around, he is neither increasing nor decreasing at that point. Does that make sense? So there's no brackets, he's only parentheses.
Okay.
So you don't put like a bracket around this guy, because he is not increasing physically exactly at that point. That point is neither increasing nor decreasing, so he's not included in any of the sets. That's why he's a parenthesis. Okay? Good? Over here. Increasing, decreasing, constant. Okay? He starts out increasing. What's that interval?
Negative infinity to 0.
Is it 0 or 1? 0, because that's the x coordinate. We're not going with y coordinates. We only care about the x's. So from negative infinity to 0, he is increasing. Then what does he do?
He's constant.
From 0 to 2. Okay? And then he turns around and he is?
Decreasing from 2 to negative
I
infinity.
didn't mean to do that. He is decreasing from 2 to infinity?
Negative infinity.
No, 2 to positive infinity. You're talking about the x coordinates. So going right, he is positive infinity. Yep. Does that make sense?
That's really going to mess with me.
Yeah. You're only caring about the x coordinates. So even though he's going down, that's not negative infinity, that's positive infinity in the x direction. Okay? So whenever you're doing this, you should have one negative infinity and one positive infinity always.
What does C stand for? Center?
C is constant.
Okay.
Constant. Constant means he doesn't change. He's a horizontal line.
Okay.
All right. Relative max and min. He is a relative max and min if in relationship to the points around him he is lower than others. So like let's say I have something that looks like this. Go like that. Okay. Let's say here's my function. Wow, that's really terrible. Okay. My maximums, my relative maximums are this guy and this guy and this guy. These are relative max. I'm going to say RM. Relative max, and relative max. Okay? Relative mins would be like this guy and this guy and this guy. Relative min, relative min, relative min. Okay. Then eventually we will start talking about something called an absolute max and an absolute min. You're fine.
Would this be all reals besides the? Where'd it go? There's open circles on 1.
All reals except 1. So x is not equal to 1. I'm not going to talk about absolute max and absolute min yet.
So 12.
I'm not going to do that.
12.
Okay, so forget what I just said. Linear functions.
118.
Sketch this function right here. They call it f of x. That's the same thing as y equals. So when we're graphing that thing, where do you start? If he's a linear function, where do you start him?
At positive 3.
At positive
And then we go down 1 over 2.
And you go down 1 over 2. 1, 2, 3. Put a dot. Down 1 over 2. Down 1 over 2. Down 1 over 2. And he looks like a straight line like that. That's what he looks like when you graph him. Good?
No.
Remember doing this?
Yeah, can you go down to even odd functions?
No, because you can wait.
Okay. Write the function for. This I think you have a question on in your homework assignment, and it's going to be kind of confusing.
What?
Just the way that they write it. They say when f of 1, when you have f of 1, it is 3, and f of 4 is 0. Okay? So what you can do is you can just write those as coordinate points. This means the x coordinate is 1. Whoa. They moved on me. The x coordinate is 1, the y coordinate is 3. So that's the ordered pair 1, 3. Okay. This is the ordered pair 4, 0. And I want to write a function out of that, like y equals mx plus b.
So you do y2 minus y1.
Okay? So the first thing that I do, my algebra kids just got done doing this. We need to find m and we need to find b. Let's find m first. To find m,
0
y2 minus y1 over x2 minus x1. So the second y coordinate is, you said 0 minus 3?
4 minus 1.
4 minus 1. So this is negative 3 over positive 3. So my slope is
Negative 1.
-1. I'll slow down for just a second.
And then plug in 4 and 0.
Are we doing okay?
What is origin symmetry?
Y equals, odd, negative 1x plus b. I need to find the b. How do I find the b?
You put 0 in for y and
Doesn't matter which one you do.
X.
Can I do this one or this one?
It'll be the same.
Doesn't matter. It will be the same. So we like 4, 0. So put 0 in for y and 4 in for x.
B equals 4.
Okay. So negative 1 times 4 is negative 4. Add the 4 over.
Y equals
B equals 4.
negative x plus 4.
So y equals negative x or negative 1x plus 4. So when they write it like this, when they say f of 1 is 3 and f of 4 is 0, that's just a funny way of saying 1, 3, 4, 0. Good?
What if that has no
Yeah?
symmetry at all?
Then it's neither.
Remember the last
Even
one?
or odd. It doesn't have to be one or the other.
Well, there's x.
No.
Well, there's no x-axis.
Well, x-axis symmetry is neither. Even or odd. Even is only y-axis. Odd is only origin. Because x-axis symmetry would be like something like this, which isn't even a function at all, because vertical line test doesn't pass. Okay? All right. Step functions. These are greatest integer functions. Greatest integer less than or equal to x. This is what I was talking to Win about just a minute ago, where he said, how do you do like the greatest integer? It's like 2 brackets of like 1.2. Okay? These you always round down. Always round down. So the greatest integer less than 1.2 is 1. The greatest integer less than 1.99999 is 1. You always round down, okay? Be careful when they get to negative numbers, because when they do like the greatest integer of negative 1.9, what is negative 1.9 round down to?
To
Negative 2, right? Okay, because it's a negative number, rounding down means 2 instead of negative 1.9. Okay, so that's what that looks like. All right, greatest integer. I do not make you do these on tests at all, because greatest integer you really don't use all that often. But what he looks like is a graph that looks like this. You'll start at 0, put an open dot, or excuse me, a closed dot. You'll go over, open dot on 1. Then you'll go up to 1, open dot on 2. Go up to 2, open dot on 3. Go up to 3, open dot on 4. Right?
What does this do?
This is the greatest integer function.
Oh my gosh, I hate it already.
Okay? So what this is doing, the greatest integer function, the way that this works, right? Okay? Story problem that goes along with greatest integer, okay? You guys are 17 years old, 18 years old,
18.
some of you, okay? So
Well,
we'll go with
16.
18, okay? So you are not 18 years old exactly, Caden. You are 18 years and How many months? How many months? How many days?
We don't know. Just like 5.
Okay, 5 months. 18 years and 5 months, okay? So this is you being 18 exactly on your birthday, okay? Caden is actually over here at 18 years, 5 months, whatever that is. Okay? But if he goes into a, like a
Is it May or
theme park or something, like he goes to Disney World, they're not going to charge him by the month or by the day or by the hour that he is, right? They charge him the same amount for him being the entire year of 18, right? Okay? Just because he's halfway through his 18th year of life. Just because you're halfway through your 18th year of life doesn't mean you pay more, right? If you're 18, that whole year you're paying the same amount until you hit your 19th birthday, and then you bounce up to the 19 level, right? And then you pay that amount until you get to your 20th birthday. Then you bounce up to the 20th year and you pay that amount until you hit 21. Does that make sense? Okay? So if you are like not on your 19th or 18th birthday exactly, if you're partway through the year, you're still on that bar. Does that make sense? That's the greatest integer function.
Teachers, please dismiss the junior high volleyball players.
Okay? All right, sketch the graph of this guy. Do I make you sketch the graph of a piecewise function on your homework assignment? I'm going to change this. I do?
Yeah.
I don't want to do that.
I already did it.
We'll do it together tomorrow. But let's do this. Let's talk about, because these are some questions that you might be asked, like on the ACT. Let's say I do f of -4. Let's say I do f of 1. And let's say I do f of 5. Okay? These are questions that you will be asked on the ACT. You will not be asked to graph this function, but if they give something like this to you, they might ask you, what is f of -4? What is f of 1? What is f of 5? Okay. To what? To identify the graph? I don't know. They might. Okay, so f of -4. What you do when you're determining this is you look at these two guys, which is the domain. Okay? So which of those top or bottom equations does -4 fit into? Does he go into the top one or does he go into the bottom one? Did we do this yesterday?
Yeah, we did.
Yeah, we did. Okay. Does he go into the top one or the bottom one?
Stats.
No, we did it in the class.
No, we did it in this class.
Calc.
No, we didn't in Calc. So which one does -4 fit into? The top one or the bottom one? Is he less than 1 or greater than 1? Less than 1. So I'm going to plug him into the top. So 2 times -4 plus 3. That is?
-8 plus 3
-5. Okay, 1. Which equation does he fit in exactly?
He is less than or equal
No,
to
the
1.
first one.
The first one, because less than or equal to 1. So I'm going to plug him into the top one. 2 times 1 plus 3? +5. Yeah?
Wow, that's a
Okay.
good change.
5 fits into the bottom one because he's greater than 1. So -5 plus 4, -1. Those types of questions you will be asked, okay? If they ask you to graph it, we'll graph it together.
That's really
Okay.
not that hard at all.
All right, even and odd functions. It is an even function if it has y-axis symmetry, which means that you are allowed to plug in -x comma y and it looks the same as it did before. Okay? It has odd symmetry if it has origin symmetry, which means you are plugging in -x and -y and it should look the same as it did before. Okay? So let's go through that again just so that we're clear what it means to look the same as it did before. Okay? So I'm going to test this one first for to see if it's an even function, which means y-axis. Okay? So I'm going to plug in -x comma y into this equation right here. Okay? G of x is treated like your y variable. Okay? We're good? So down here, I'm gonna take the y and I'm gonna leave him the same, but every time I see an x, I'm going to plug a negative in. So y is gonna stay the same. The x's are gonna become -x. I'm gonna plug a -x in for every place that I see an x. Okay? So if I take -x and cube it, does it stay a -x cubed or does it become a +x cubed? It stays -x cubed, -x cubed. Okay? Then -x is gonna become +x. Okay? Is this the same equation as I had before?
Yes. No.
No, it's not.
The last one's positive, so no.
So it's -x cubed plus x, which is kind of the opposite of what this guy is. But is everything the opposite?
No.
No.
Yes. No. No.
No.
The y is.
The answer's no. It's
Okay,
not
so this is
even.
not even, not an even function. It's not even an even function. Huh? Okay, whatever. Anyway, origin symmetry. Origin or an odd function means that I'm going to plug negative x and negative y in. Okay, this is the kicker. This is the weird part. So the y, I'm going to also make it negative. The x's, I'm going to make them negative.
It's neither.
You just wait. You just wait, dearie.
Oh gosh.
Okay?
No.
Negative y equals, we said negative x cubed stayed negative x cubed. We said this guy becomes positive x. That is not the same thing as what I had before, except
Oh my god.
Oh my God,
if I
you
divide
everything.
if you divide everything by a negative 1, this becomes positive y equals positive x cubed minus x. Because I divided everything by a negative 1 and he flipped back to the original, it does have origin symmetry.
Oh my gosh.
Does that make sense?
You're so smart.
Oh my gosh.
I hate
Oh my
that
gosh.
because it's gonna
Okay?
screw me up all the time.
So basically, if it turns back to the original or every single thing is an opposite sign of the original, meaning you could divide by negative 1 and flip it back, then it has that type of symmetry, whatever you're doing, right? Okay, usually that happens with origin symmetry. You can divide by a negative. Okay, so here's my y. I'm going to test for even function,
It will be even, but
which
it will
is
not be odd.
y-axis. So I'm going to plug negative x comma y. So the y is going to stay the same. Negative x squared plus 1.
Is x squared plus 1.
Negative x squared
Positive.
is exactly the same thing as saying positive x squared, because negative x times negative x is positive x squared. So y equals x squared plus 1. Is that the same thing as what I had before?
It's even, not
Yes, it is an even function. Can it be even and odd both at the same time? Can it have y-axis symmetry and be origin symmetry at the same time? This is a legit question. So, like, can I stop here, basically? If I know that it's an even function, do I even have to test for it being an odd function?
Because it can only be one or the other. No, wait.
Can it be both?
on. It could be
both.
neither.
What does that have to look like in order for it to be both?
Perfect.
That's exactly right. It's a circle, right? Okay.
I was gonna say square.
So that pretend it's a uniform circle and not my circle, okay? This is symmetric with respect to the y-axis, and it's symmetric with respect to the origin, because everything that's in the first quadrant is also in the third quadrant, and everything that's in the second quadrant is also in the fourth quadrant. So it is an origin symmetry and y-axis symmetry. This guy, if I check him for origin symmetry, if you want to put this in here, we know he's not going to be, but negative x and negative y. If I switch him, the y will stay negative, the x will become positive again, but this is not the same thing as what I had to start with, because that y is negative. So it's not an odd function. It's not odd,
What would
it is
what would
even. Does it have to be one or the other? We know it can be both if you have a circle. Does it have to be one or the other, or could it be neither?
It can be neither.
It can be neither. It does not have to be one or the other. Okay? So there's that.
What would the x look like if it was a circle?
What do you mean?
Like, would be x to the what?
Like what's
Oh, what's the equation for a
Yeah.
circle? So it has to be some form of x squared plus y squared equals like a number, like 4. So this guy is the equation of a circle.
The radius then?
No, the square root of 4 is the radius. This is a circle with a center of 0, 0,
Diameter.
and the radius is 2.
Okay.
Yeah. Yeah.
So it just looks
Now,
like
if this is 16, 16 is not the diameter. 8 is the diameter,
Yeah.
because the square root of 16 is 4, and that's the radius, so the diameter would be 8. So it's not
So
necessarily
16 is
this
the
number.
diameter.
No, 16 is not the diameter. So let's say instead, I'm going to put 16 in here. The square root of that number is the radius, right?
Mhm.
Square root of 16 is 4. So what's the diameter?
Would be 8.
8.
Okay.
So this number is not the diameter. The square root of that number is the radius.
Okay.
Yeah? Okay, so this is what would have to happen in order for it to have both y-axis and origin symmetry. It would have to have x squared and y squared.
Right, come on.
Okay?
Stop
Good?
the video.
All right, stop the video. Bye.